Hi again. Today I'm going to show you another Python tutorial connecting to the 30-day map challenge. This day's topic, which is actually day number 4, is about our own data, for which I'm going to show you how you can create and visualize your commuting map. I picked about 100 car trips from the past 1 year, and for each trip I only logged the origin and the destination, and then I built a Python pipeline which geocodes these locations and then plans a possibly optimal route between them using OpenStreetMap. After these processing steps, as you will see, I created a static map visualization which sort of looks like an electronic motherboard using these funky, techy, simplistic colors and minimalistic design. So let's see how this works out in Python. In order to properly visualize my personal driving and car trip data, first we will need to do a few basic imports and then read in the dataset. I will make sure that I will only count and visualize trips from Budapest so that the map will be contained to one city. And I also have to note and remark that I changed a bunch of addresses here, so they look like the ones I was actually visiting, but they are not, just to make sure that my privacy is preserved at least to some extent. So we will actually just need the from and the to columns. And these are addresses in Budapest. Let's turn these into two lists. And then to be able to properly visualize my trips, I will actually also not use, and I'm intentionally not using the exact GPS logs, but just the addresses, because then I will be able to compute the routes, the possible routes myself. So let's pick a random trip like trip ID 2, and from these two lists, let's pick the origin and destination, and then use OSM1X geocoder, which will map these addresses into road network points. And then we will get a road network centered to the origin point with a distance or a radius of, in this example, 3 kilometers. So here we will pick the starting destination, rephrase. Here we will pick the starting location, map it into the OSM road network, and then query a road network from that area. So on the map, here you can see that these are the locations, and here this is the number of nodes. So we have about 2.5K nodes in the selected area. Then, since we have the graph and the locations, now we will need to map them to the OSM network directly. So we will have the ID, the OSM ID of the nearest road network intersections or road network nodes, which we will be able to use to compute the shortest path between. So here we are assuming that we are using a drivable road network, but this may deviate a little bit from what Google Maps shows us depending on the daily traffic. Anyways, I would like to show which parts of the city I usually visit, so this is good enough for us, a series of consecutive OSM road network node IDs. And we can also use the built-in visualizer of OSM1X to put this very quickly on a map. And yep, here we are. This is one side of the city Budapest, and here you can see one that might be my home location and one might be, for example, a train station. Maybe we can decrease the map size a little bit, but we will do it in the next part of the tutorial. So let's see how many trips I included here. More than 100. So that's pretty good. Let's process them all and put all of them on one single map, so I will have a nice sort of heat map consisting of road segment line strings. So first, let's pick the origin point. Let's assume that it's going to be the first address and draw a fairly large graph around it, bigger than the one here, with a distance per meter of 5 kilometers, but we might increase it further later on. Then in a for loop, we will iterate over all the trip IDs, and for each iteration, we will query the origin and the destination address, and then repeat the previous steps, get the location geocode these addresses, then map them to OSM road network IDs, and then compute the route. Here I will add this lazy condition because it might happen that some of the addresses won't be possible to geocode, maybe because of the language or any other reason. So I would like to bypass those situations, and then we will see how many routes we will end up having here. So since here we are geocoding and processing, we forgot to define the result array. So we have 92 routes, which is good enough for now because this is more like a tutorial and not a real client project. If it was a client project, then I would probably experiment with different geocoders and also would have a look manually by eye on those addresses which were not possible to geocode. But for now, this is good enough for us. And now let's go and visualize these routes. First, I will visualize the graph in a pretty subtle design. So we have this dark gray color and very thin lines. So this is our base map here. And then in a for loop, I will visualize all the 100 routes, or 92 routes. For that, again, we have a nice built-in command in OSMNX. So we will just pick the graph where we would like to draw the routes on. We pick the route, the series of node IDs, select the axis and customize the plot. Here I will still use the bright yellow color. And here we keep the figure open, but we are not showing it. So we will be able to layer all the route plots on each other. And we will only show the map at the very end. So now we will let this for loop to plot all the routes on the map, and then we will have this very nice, very interesting looking map, which almost looks like, like an electric motherboard. And you can play around with the opacity, which is the last parameter in the route color field. We can decrease it. We can also change the route line width, so it will be a bit less intense. So let's see how it looks like. Yeah, it looks nice. Maybe it's actually better. And we have these markers as well. So after having this detailed look into my traveling habits and schedules, and I really wonder what has happened there, for example, but we arrived to the end of this tutorial, so please let me know if you were able to find any of your travel logs and recreate any of your trips and or commuting patterns using Python. Thank you for following this video through, and see you next time.